Shall we start? Okay.
Hi everyone, let me know if I'm audible to everyone. Okay, thanks for letting me know. A very good, warm good evening to each and every one of you present over here. Today, I welcome you to the fourth day of Machine Learning Study Jam. And today we will be covering what a basic introduction to machine learning, like fundamentals of machine learning, its application, key concepts, and what are the important topics that you should cover in machine learning when you are dealing with machine learning. So just a quick recap of whatever we have done till now. So in the first day we had a basic intro to what some Python functions and NumPy library as well. On the second day we had an introduction to pandas library, and then on third day we had some pre-machine learning classes in which we discussed some statistics, some maths that are like very important, which are considered as very important topics of machine learning. And today we stand here for the fourth day of Machine Learning Study Jam, which is ML Study Jam. And today we will be covering a basic introduction to machine learning, application, key features, and what are the other topics that are important in machine learning. So today's session will be taken up by Aditya Shaw, and I would like to hand over to Aditya from now on. I warmly welcome Aditya to the show.
Thank you, Tisha, for the warm welcome. And hi, everyone. Good evening. So, today we are going to start from Introduction to Machine Learning, and we will just cover the types and applications, why we are using machine learning in today's world, and what are its future aspects, and what are the key terminologies that you should know as a beginner to enhance your machine learning knowledge. So, if I'm clearly audible to you, can you just give me a yes in the chat? Okay, thank you. So I'm just sharing my screen and we'll start. Is my screen visible?
Yes, Aditya, your screen is visible.
Okay, thank you. Yeah. So before starting any topic, let's just go through this meme. So what it says that there is an elephant who is marked by algorithm, and here it is a penguin which is marked by maths. So if we combine these two, the result occurs like machine learning. So this man says, "What the hell is this?" So are you okay with this meme? Like, are you if this meme is given to you, should you be able to say true or false? Is this statement true or is this statement false for you? Like, I want to know from the audience. Yeah, true, true. Okay, no issues. So yeah, you can say machine learning is a mixture of both algorithms and maths, and whatever the product we just make, it looks like this, but it's not exactly. It's a meme. So yeah, we can learn from it also. So it's a good way of learning is visuals. If we follow any visuals, the more time the less time we need to recall any topic. So let's just start from the definition of the machine learning. I would like to say that I would be keeping this session interactive, and I would be asking a little simple questions to the audience. So please be interactive in the chat and show your curiosity. Even if you know the wrong answer, there is no harm to say anything. Just be interactive and just be curious. If you don't know anything, then also we don't have any problem with that. So let's just start. So let's first keep the definition on. So what it says that machine learning is a subset of artificial intelligence. Yeah, it's okay. Artificial intelligence is a bigger set, like it's a universal set, and machine learning is just a subset of that. Okay, and ML involves deep developing algorithm and statistical models. So let's understand it through this example, like this figure over which my cursor is moving. So in classical programming and other programming languages, what happens? Like we give rules and data to our computer or the program, and it gives us some answer. Like we give some C programming. Like we take some example of C programming. Like anyone give us a question, make us a simple interest program, and show me the output. So it will be classified as a classical programming. And what happens in machine learning is we give data and answers to our model. This is the representation of a model. So and it gives us the rules. So this is the machine learning. Here the key difference is we provide the rules in the classical programming as an input, but we are having the input as our output in machine learning. So it is a difference in classical programming and machine learning. We are already knowing the answers, but we are looking forward for the rules, what rules it have, and it will show to us. So let's understand from more points. The goal is to enable computer to learn from data and make predictions or decisions. Yeah, the machine learning models are just the something that predicts something, like that predicts something which can happen in future, and the prediction can be wrong or right, it doesn't matter, but it is predicting something that can be happened, and that is a possibility of happening of that event or outcome. So the ML models deals like that. So ML doesn't require explicit programming for each task. Yeah, ML doesn't need explicit programming for each task. ML, what we can do is we can give the total data set to the ML model, and it can give you the output. So it doesn't require a particular program for the particular data set. You can categorize your data set into a whole, and then you can uh, discover the output after it comes out from the ML model. So it is just a mimics of the humans, like how we learn. Suppose we are learning something and we are making mistakes. So what we are doing in the next time is we are trying to minimize those mistakes. Just like this happens in the machine learning models also. In the machine learning, what happens? A model is trained in such a way that is, if it do something wrong or give some wrong output, we again give some input to it, like we will show it that this is wrong or this is right, and again after recompiling it, it generates the correct one. So it learns by making mistakes, then correcting those mistakes, then comes out with the correct output. So this is the basic definition of machine learning. So why we are using ML? So before moving to this, is there any doubt in the definition of machine learning? You can say in the chat. Okay, I guess there is no doubt. So let's move on to the why we are having machine learning. So we have various problems in our day-to-day life, like email spam filtering, production recommendation, predictive text autocorrect, voice assistant, fraud detection, traffic prediction. So all these problems involve human effort, and all these problems involves the cost of solving it. So why we are having ML, as like ML do the this type of handles this type of situation and does it for us. Like the models is designed in such a way that it does the tasks for the humans, and in that way we reduces the human effort, we reduces the cost of utilizing the human effort, and overall it benefits us in various ways. The ways are shown in this diagram, like it reduces the reduction cost of the company, the customer insights and intelligence gets increased, improving the customer experience. Yeah, it that matters a lot in the industry. Like the customer is the prime focus for any industry or any brand. Like they are focusing on the customer behavior. If the customer is happy, the your brand would be a success, and if your customer is not happy with your brand or product, your brand would not get that success like the previous one. So the prime focus is making the models in such a way that it can handle the error faults happening in the industry or happening in any of the market scenarios, like we encounter in the real life. So moving on to further, let's learn about the types of machine learning. So before learning it, let me check chat. Okay, yeah. So basically, in various book, there are various types of machine learnings are given. So what we can figure out is there are mainly four types. Apart from these four types, there can be possibility that further any type can occur, or you can come up with another type. There is not any issue, but mainly I have categorized this into four types, like supervised, unsupervised, semi-supervised, and reinforcement. So in supervised, what happens? Housing price prediction, medical imaging, this type of example we can see in the supervised. And let just understand it using this figure. So this is a figure that represents the supervised learning. What happens? We give labeled dataset. Labeled dataset means fetch we give the input to the machine learning model, and we just named that data set, like this is cat, this is dog, this is again cat, this is again dog, this is again the type of cat. So we labeled those data set and we give it to our machine learning model, and it creates the logical model of it. And then we fetch some unknown data to it, like if we have given a dog called labrador in this, so we have given a dog, suppose Doberman in this category. So it identifies like that the Doberman is a category from a dog. Okay. And similarly, if we give any breed from a cat, like I don't know a particular breed of cat. So if suppose we give a X breed cat to machine learning model first, and after the logical model is created, and if we give Y type of cat to the machine learning model, it will say that it is a type of cat. uh, However, it doesn't give you the idea about what type of cat it is, but it will surely don't say that it is not, it is a dog. It will surely say that it is 100% a cat. So this is what supervised learning is. We are already saying the data which is labeled to the machine learning model, and it is creating a logical model, and then we are giving some unknown data to the model, and it is predicting whether it is labeled one like the earlier or not. But like it is just categorizing it into the other labeled one in the previous. So this is what the supervised learning means. Let us understand this by the definition. In the supervised learning, the model is trained on the labeled dataset, which I have said, where each input is associated with a corresponding output label. For the every input which we provide, there would be a output label associated. Means the output label and input labels are fixed here. So examples of this are classification like spam detection, image recognition, regression, predicting house price, stock prices. These are all examples of supervised learning. So what happened in classification is like we classify some of the inputs, and we generate the output according to that only. And what happens in regression? The regression part would be uh, covered in the later part. You would not understand regression in this video. Like you need to understand the further topics also to understand this regression, so I am leaving it to here. But the classification one is easy, like we just classify the data set and it generates the data according to that only. So let's just move on to the unsupervised learning. So let's understand it. So here is a meme for the supervised. I think it is blur, but what this meme says, like this lady is identifying that he is the dad of her son is this one. So after learning that, the this suppose this is the model, this child is the ML model. So every time it sees the object like this, he identifies as his daddy. So every time he is seeing that object like this, he is identifying his daddy. So what happens? It is similar to the supervised learning. We feed some data, input data, and whenever machine learning models encounters it, it says that it is that type of data which you have fetched. So let's move on to the unsupervised one. So we give input raw data. So here the datas are not labeled. Here we haven't mentioned that this is circle, this is square, this is triangle. So we are not labeling the data, and we are just providing it to our ML algorithm or ML model, you can say. And the ML model will be predicting and categorizing it, like this is the bunch of squares, this is the bunch of triangles, and this is the bunch of circles. So you are not giving anything to the algorithm, but the algorithm is still able to categorize it into different types. So this is called the unsupervised learning. Unsupervised, the word clearly states that you are not giving any supervision to your model. Still, the model is able to classify the types. So here is a meme also for the unsupervised one. So here the Batman says that use unsupervised learning. The dataset has no level, so because the dataset is no level, having no level, so he says that use unsupervised learning. So let's move on to the third one. Yeah, before moving to the third one, are you having any doubt here? Okay, thank you. So let's move on to the third one. The third one is, yeah, the third one is semi-supervised learning. I would come back to these definitions also. These are just the theory part. I would cover it, but if you understand the logic of this theory part, you would surely understand theory as well. So I would cover it later on. First, just understand it through the visuals. So let's move on to the semi-supervised one. So in semi-supervised, what happens? Their input data sets are there, and there are partial label. Partial label means there you can see apple, banana, orange is there. Okay, and we are just labeling the orange as orange and banana as banana. We are not saying the machine learning model that this is an apple. If you are not saying anything to a machine learning model, so it is known as unlabeled data, and if you are saying, so it is known as labeled data. Here labeled data identifies the partial labels because this data set is not complete as this. So the machine learning model having this data set takes up, and if we give an apple to the machine learning model, what happens? It generates and it predicts that it is an apple. So it is the ability of the semi-supervised learning models that having the partial label data and the input data set, it is able to predict the unlabeled data also. So this is the way that is used in semi-supervised learning. And after that, let's see. Yeah, we are having a meme also for this. Learns from the large amount of unlabeled data and some labeled data. Semi-supervised learning success. So it learns from large amount of unlabeled data and some of the labeled data. Like it is having, suppose you can say this is 80% of data which is not labeled, and here two data you are labeling it. Suppose you are saying 20% of the data is labeled here, so it is generating that the data, that the prediction is apple, and which is unlabeled data. So let's move on to the fourth one. After that we would see the definition, proper definition of it, but before it, let's just understand from the visuals only. So reinforcement learning. Reinforcement, this learning is a very basic example of something which you can observe in your real life also. What is reinforcement learning? Let's just see. So we are having an input data and we are not providing any label. So we are giving it to our machine learning model and it is saying it is a mango. So we are giving the feedback to the machine learning model that wrong, it's an apple. We are providing this feedback to here. Okay, so after that it says, yeah, I have noted this, and the next time if we are asking what is this, if we are providing an apple and a question with that, so it predicts that it's an apple. So what happens here is the machine learning model is learning from its mistakes. So in the real life also, what happens, a human is something that we learn from our mistakes. Suppose we are doing any task and we fail to do that task, so again we want to do that task. So what we can do is we recognize our mistakes and we just think in our mind that that mistake should not occur in the second time. So this is what the reinforcement learning came from. So it is basically the mimic of human activities also, you can say. So we are giving unlabeled data to the machine learning model. It is giving a wrong answer. We are providing the correct answer to it, and it is noting that, and it is not doing the same mistake again. So this is what the reinforcement learning means. So here we can we are having two more memes for the reinforcement learning. So in the first one is a boy is standing here, which is an ML engineer, and he has two paths. First path is supervised and unsupervised, which is the guided part, which is the path of you can say heaven, and it leads to the good palace, you can say that. And here is a path where the uh, we can say the helps are not there, like the input datas and labels are not there, but still he wants to reach, and it's a path of, you can say, the thrones, or you can say the path of hell, because you are not having any support from the user in this path, but you are having some kind of support in this path. So if you are having support in your life, so you can travel through the path easily. But if you are not having the support in your life, here you can see the path is broken down between. so he needs to do something else to reach the destination. So here is also an example of reinforcement learning. The supervised learning here is strong, unsupervised is also strong, but reinforcement learning looks like not so strong, but it looks like a joke also. So let's just move back to the definition part. So what does semi-supervised learning means? It combines the elements of supervised and unsupervised. Like it combines labeled data set from there and partial labeled data set from unsupervised and mix it where the model is trained on a mix. Like see, you can see the mix word, mix of labels and unlabeled data. And let's see the example: training a model with a small label data set and a large label data set to improve performance. So it basically works on small and mixture of small and a large unlabeled or labeled data, and it gives the performance based on that only. So let's move on to the definition of reinforcement learning. So what does it mean? So reinforcement learning involves training an agent to make decisions by interacting with environment and receiving rewards or penalties based on its action. Like suppose if you are doing a daily task in your home, and if you found any difficulties, so suppose your mom came and say you he she scolded you for doing the wrong task. So what you gather some inputs from there, like if you do that same task again, so let's say that after 1 or 2 days you are told to do the same task again. So what you can do is you would not repeat the same mistake, because you are having in your mind that if I do the same mistake my mom would scold me. So this type of learning is known as reinforcement learning. So let's see the example of reinforcement learning. First example is game playing, AlphaGo, robotics control. Like in the robotics also, if some mistakes is happening, the robots are programmed in such a way that it doesn't repeat that same mistakes. And autonomous driving, yeah, it's Tesla driving cars are the good examples of reinforcement learning. Like in the previous one, if they when the Tesla cars are being constructed earlier, so there are a lot of mistakes were happening in the environment which they were tested. So after that what happened, they tested on the regular basis, and the model is now capable of t- uh, identifying the objects in the environment, and it doesn't repeat the same mistakes happening in the previous one. So yeah, these are all the four types of machine learning. And if you are having any doubt, please write it in the chat so that I can see it. Okay, so let's move on to the next one. Yeah, so let's move on to this one. Like before moving to the core ML, you need to understand some basic terms. Okay, so what are those terms? Are first one is algorithm, and its notation is a. Here the notations are based on a particular person or particular book, and you can also make your notations. There are no hard and fast rule that this thing would be represented by this only. Notations are just symbols that is convenient, that is a way which is convenient to the users or the persons who are using it. So the it is based on the user that is going to use it, so he she can change the notation as per the uh, per themselves only. There is no hard and fast rule for that. So let's just understand the algorithm. The algorithm is a set of rules, you can say, or not rules, you can say it's a set of steps. So which is fetched into the machine learning models, and it is told to perform this task according to that steps only. So in real life also, real life example, we can see that there are some rules in every sphere of life. Like if you are playing football, there are some rules. So if you don't follow the rules, you would be penalized or you would be given red or yellow cards like that. So these are just the examples of algorithm. We can't say directly that those are the examples of algorithm, but we can understand from it that it those are also the set of steps that you need to follow. Okay, So linear regression algorithm predicts the house prices based on features. So features, we will discuss the features later on. So what is linear regression? It is an algorithm in ML which just predicts the house prices. Yeah, you can use this algorithm to predict the house prices. Okay, now let's understand model. What is a model? It is notated by M symbol, and model is something which is just replicating the task for us. Like anything can be called as model, but it is a program in ML which is the core part of the ML which is going to do the task for us, and which is just having the programs and the set of steps and all, and which is just going to predict something, or which is just going to uh, give you the steps like you need to follow, or future predictions and all. This is just the model's definition. Dataset. What is dataset? Dataset is just the values or the data is given to you, and on that value you are asked to predict something. And datasets are, you can say, like, if I can give you an example, dataset like the height of a height of the number of students in a class. This can be called as dataset. The birth dates of the person in the class, this can be treated as the dataset, and so on. There can be a multiple example of datasets also. We can discuss it in the further lectures also. So let's move on to the feature one. Yeah, the feature one is represented by X. Example, feature matrix with columns like size, bedroom, location. Suppose there are, let me show you table. So here in this table you can see student ID, exam 1 score, exam 2 score, study hours, pass and fail. So here yellow columns are the features. Okay, and this whole set is a data set. Okay, and in this data set, if we apply any algorithm, so it is together would be known as the ML model. And if it predicts something, it would be known as the prediction or the output. So the input is this part, red to orange, and the output is this part, green part. Okay, so now just look at the label. What is label? So labels are the house prices, are the labels for each house in the data set. So you can say, let us give you one more example. Yeah. So you can say the X as a input variable or feature, Y as a output variable, target variable. You can say this as a label, or you can treat X as a label, because here I have one more example. See, this you can say this you can say label, because it has some data and it has some labeled also. Like it is denoting that it is orange, not a banana, and it is denoting that it is particularly banana, not grapes. So it is called labeling. Labeling means you are naming the data set, the particular values of the data set, just that. Training set. What does training set denote? Training set means the amount of data you want to train. Suppose there are the have we are having the five datas of 5 students, and we are training them. And if we are having suppose 500 students in the class, and we are just training 5 students, we are just keeping the track of 5 students, and we are giving it to our ML model. So it would be categorized as the training set, because we are just training the 5 data from out from the 500 set. So what is validation set? Validation set used to tune hyperparameters. This this thing you would not be understand in today. So what you can do is you can research about this, because this is a advanced topic. Like, what is validation set? If it can be explained in the further lectures. Like if we encounter linear regression or KNN algorithm, this type of algorithm, in this you can deal with the validation set. So I am leaving this part here. So what is test set? Test set is something which we are testing. So suppose 1 2 3 4 5, and we are testing this. So this would be categorized as a test set. So yeah, uh, this was the thing. And let me introduce some more terms to you. Suppose we are having X as an input variable, it would be called as a feature, and Y as the output variable, so it would be called as output variable or target variable. that we want to generate. So m would, and m, if we are classifying m as a number of training example, and x comma y would represent here the single training example, and here x, here it denotes the power sign, x to the power I, and y to the power I, it denotes the ith training, ith, where I is the row number of the data set. Suppose we are having, let's just see here, we are having 5 rows of data set, 1 2 3 4 5. So I value would be first 1, then 2, then 3, then 4, then 5. So here you can, yeah, here the first I value would be 1, then I, x to the power of 1, y to the power of 1, that would represent this one, first 1, then first one is pass. Okay, then x to the power of 2, y to the power of 2 would represent 2, he is also pass. Then x to the power of 3 and y to the power of 3, and he is 3 comma fail, he got failed in the exam. Okay, so yeah, that was all from this session. I guess it was a crisp session because we just have a basic understanding of the machine learning, and we just have the introductory part. If you have any doubt on that, you can please ask. Okay, thank you. Yeah, I included some of the memes because from memes and from visuals we understand better as from written text. So this is my way of teaching some topics also. And I haven't include any code in this PPT because I didn't want to make it bulkier. I just wanted the uh, audience here to understand first the meaning of this all definitions, and in the further lectures that is taken by other speakers, so he she would try to give try to basically he she would try to give you the codes. There is no boundary on that. So haven't kept the codes here because I felt that if we put codes first and before the understanding, then the people watching this lecture would fail to understand the definition and the core part, and they would just try to cram the code and try copy pasting. So yeah, for that reason I haven't put it the code here. Yeah, that's all from my end. Ashmi, Tisha, are you here?
Yeah, yeah, I'm there on the call.
Okay.
We hope you guys got a clear, concise definitions and understanding of what machine learning is. And we hope that you enjoyed the session so far because it was just filled with the memes that you love. Very thank you so much, Aditya, for covering all these topics. And if you guys in the audience have any kind of doubts, you can just text in the chat right now. We are open for 2 minutes more. Or after the session, if you go through the topics when the materials are all uploaded, and you can just have again, you just have doubt again, so you can just takes the doubt in the doubts section or in the discussion session, whatever suits or whatever you think is the best option to go with. You can just text there and we will just reply as soon as possible. So is there any doubt, guys? Can- Okay, so as there is no doubt, we will end the session here. Thank you so much, everyone, for joining, and thank you, Aditya, for taking this wonderful session so far.